In this video, we are going to create your very own first-person movement in Godot from the ground up. You'll learn which nodes to use and how to create a script in GDScript to handle the gravity, running, jumping and turning of the player. By the end, you'll have a grasp of the basics on player movement, as well as your own template for your future games. Hope you guys like it. Let's get started. Let's start from a new blank project and set up our main scene. The first thing we're going to do is create a 3D scene. Rename the node to main and save the scene. Let's already set this scene as a main scene by right-clicking on the scene and clicking on Set as Main Scene. If you go ahead and click play, you can see we have a small window. But I want it to be full screen, so let's take care of that. At the top on Project, go to Project Settings. Inside, go to the Window tab and change the size mode from windowed to full screen. If you now run your game again, you can see that it is now full screen. Perfect. Now, before creating the world and the player, let's go ahead and create a world environment and a directional light, so we can see everything in our game. We could add the nodes manually and set up everything manually, but I want to use the default nodes currently used in the editor. To do that, we can go to the top and click on these three dots. Here we get a preview for the current directional light and the environment. And one cool thing we can do is add the current settings directly onto our scene by clicking Add Sun to add the directional light and Add Environment to add the world environment. Perfect. Let's now create our world. Create a new 3D node and change its name to World. We need a plane for the player to walk. Add a node of type Static Body 3D and rename it to Plane. Inside our static body, we will need a collision and a mesh. Let's start by adding the collision first by adding a Collision Shape 3D node onto the plane. Since this is going to be a plane, then we can go ahead and change the shape to a new World Boundary Shape 3D. This collision is going stretch onto infinity for the Z and X plane. Next, we need to add the mesh for our plane. Add a node onto the static body of the type Mesh Instance 3D. Then, on the mesh property, change it to a new Plane Mesh. If you click on the mesh, you can see all of its properties. Let's change the size of our mesh to be something like 20 meters on both axes. Bear in mind that the collision is going to stretch onto infinity, so even if the character goes outside the 20-meter mesh, it will not fall. This is just so we have a visual reference of the floor. I also want to change the color of the floor, so let's add a new Standard Material 3D on the Material property. Open the material and go to the Albedo property to change the color. I want something that resembles grass, so let's change it to a green color. Perfect. We now have a plane for us to play around with our character. One more thing I want to do before we get into the character setup is to create a few objects for the player to interact with. So, under the World node, let's add a simple node 3D to group all of the objects in our world. You can go with whichever objects you prefer, but I'm going to go with boxes, so let's rename this node to such. To create a box, add a new child node of type Static Body 3D. And inside, add a Collision Shape node and a Mesh Instance node. Let's change our mesh into a box mesh. Add a new standard material and change the color to whatever you prefer. I'm going to go with purple. Let's now move our box to be on top of the plane instead of being in the middle. Select the static body first, so when we move it, it will also move the collision and the mesh. And let's simply change the Y coordinate to 0.5. Perfect. Change the name of the node to Cube, and on the collision node, change the shape to a new Box Shape 3D. We don't need to change the size of the shape because by default, it is going to be 1 by 1 by 1, which is the same size of the mesh. Now let's just duplicate a few of these cubes and spread them around our plane, as well as rotate them just so we have some obstacles for the player. It's time to create our player. So, in our main node, let's add a child node of the type Character Body 3D. Like the static body node, the character body is going to need a collision node. So let's go ahead and add a Collision Shape 3D node. we can already go ahead and choose whatever shape we prefer. I'm going to go with the default shape for characters, which is the capsule shape 3D. Move the character a little bit more to the top, so we have some space from the ground to then test the gravity. Now that we have our character's collision, the only thing that we're missing is the camera. Inside the character body, add a child node of type camera 3D. Now, depending on your game, you might want to have the camera a little bit lower or on top of the character. But in this case, we are just going to go with the top and a little bit onto the front of the character, so we can sort of mimic the perspective of the character's eyes. If we go ahead and click play, we can see our plane, the boxes, the environment, and the lighting. Of course, we still can't do anything, so let's take care of that. Let's start by renaming our character body gnome to player. To handle the logic of our character, right-click on the player node and click on Attach Script. Rename the file to player.gd. We could use the pre-made template for a basic first-person movement, but I want to build this from scratch with you guys, so you can better understand the fundamentals and have a solid foundation into building your very own customized player movement. So let's just untick the template option and click on Create. As you can see, we now have a blank script only extending all of the character body 3D functionality. The first thing we are going to take care of is the gravity of the player. Let's start by creating a variable for the gravity of type float with a value of 9.8. Override the physics process function to handle all of our player's physics logic. To apply the gravity onto the player, we first need to check if the player is touching the ground. Godot comes with some nice built-in functions to handle cases like this, and the one we are looking for is the isOnFloor function. So, if the player is not on the floor, let's apply the gravity by decrementing the player's current velocity on the y-axis with the gravity value we've defined. This will push the character down onto the floor with increased velocity every time the process function is called. Or, in other words, it will make the player fall faster and faster until it collides with some object. To avoid any kind of visual jitter or inconsistency, we need to also multiply the gravity with the delta value we get from the process function. Lastly, we need to tell the engine to apply these changes. To do that, at the end of our process function, we'll call the move and slide function. This is going to move the player with the new values applied, and if it hits an object, it is going to slide the objects with the correspondent values. Before we hit play and test the gravity, let's go back onto our 3D scene, and let's move the player up a bit more, so we have more space between him and the plane in order to check if the gravity is working. Go ahead and save everything and click play. Perfect. Not only did the player fall, but it also collided with the plane. For the jumping mechanism, let's go ahead and add another variable, and let's call it jump force. It's also going to be of type float, and it's going to have a value of 4.5. This will be the amount of force we are going to apply to the character's y velocity. So the greater the force, the higher it will jump. In order to apply this force, we need to know when the player wants the character to jump. We could check in the code if the player pressed a specific key on the keyboard, for example the spacebar. But if we're playing this game on the console, then our code won't work. Or let's say that in the future we want to change the jump action to be applied when pressing D instead of the spacebar. Now we would need to change everywhere in our game, and it can get very hard to track all of these changes, make our code prone to bugs. A better way to do this is by using input maps. And to do that, open the project settings and go to the Input Map tab. From here, we can add generalized actions like jumping, and then map all of the keys we want to trigger that action. So, let's add a new action called jump and click on the plus icon to map an input to the jump action. To select the input, either search for it in the presented list or simply press the input you want on the keyboard or the controller, and Godot will automatically detect it for you. For our project, press the spacebar and then simply click OK. We now have the spacebar mapped to the jump action. In our code, we can now check if the user pressed the jump button by using the isActionJustPressed function from the input class and passing inside a string with the name of the action we want to check. But just checking if the player pressed the jump button is not enough. We also need to check if the player is on the floor. Otherwise, the player would be able to continuously jump, giving the player the ability to almost fly with the character. So, if the player pressed jump and the character is on the floor, then simply change the Y velocity to be equal to the jump force. And that's it. Let's go ahead and click play and test everything. So the player falls and collides with the plane. And if we now hit the space bar, you can see our character jumping up and down. Perfect. For the character's movement, let's go ahead and start by creating all of the actions that we need. So back in the project settings, let's add the needed actions. Let's start with the move left action, the move right, move forward, and move back. To move left, map the A button. For the right, the D button. W for forward and S to move back. We could already check if the player is pressing the buttons by using the is action just pressed. But there is a better way. We can get a vector of the currently pressed actions by using the getVector function from the input class. So let's go ahead and create a new variable called inputDirection and call the function with all of the actions we want to check for the movement. We now have the pressed actions represented as a vector. Create a new variable called direction that represents the direction we want the character to move. Multiply the transform basis with a new vector 3D and switch the y coordinate with the z-axis. We don't want to change the values of the y-axis because we only want to make the character move on the plane and not on the height of the world. We also just want to know the direction to move to. We don't want to know how much should we move in a certain direction. So, wrap everything in parentheses and call the normalize function to normalize our 3D vector. Now that we have our direction, the only thing we're missing is to change the velocity on the x-axis to be the same as the value of the direction on the x-axis. The same goes for the z-axis. Before we press play, let's fix a mistake we've made. In order for our code to work the way it is, we need to switch the order of the actions on the getVector function. Otherwise, the character will move in directions different to the ones we've pressed. So we need to check first the move left, then the move right, the move forward, and finally the move back in this order. So let's go ahead and click play again. And there you go. We now have our player moving. Perfect. But the character is moving a little bit slow for my taste. Let's fix that by going on to the top of our code and creating a new variable of type float called movement speed with a value of 5. In order to apply this changeable speed to the character, we simply need to multiply it to our direction in order to define how much does the character need to move in a given time. If we hit play, we can see that it is moving much faster than before. I also want to be able to sprint on command. To do that, let's go back onto our project settings and under the Input Map tab, create a new action called Sprint. I'm going to map this action to the Shift button on my keyboard. Back in our code, let's create a new variable called Sprint Speed and give it a value of 10, the double of the movement speed. So now we have two values for the speed of our character, one for when we are walking and another one for when we are sprinting. Before applying this new speed onto the direction of the character, let's first check whether the player is pressing sprint or not. Create a new variable called isSprinting and assign the value we get from the isActionJustPressed function from the input class. We now want to create a new variable called speed, which will be equal to the sprinting speed if the player is sprinting. Otherwise, it's going to be equal to the movement speed. Now, instead of multiplying the direction with the movement speed, we simply multiply it with the speed. Before we hit play, you might have noticed that this is not going to work the way you would expect. This is because of the function we are using to check if the player is pressing the sprint action. This function will return true once the key is pressed. But if you continue to hold the key down, it will return false. This behavior is perfect for actions like jumping, which we only want to apply the jump force at the time the player pressed the key and not while it is still holding it. But for the sprint, we want to apply the speed while the player is still holding the button. In order to fix this, we only need to change the isActionJustPressed function with the isActionPressed function. So let's go ahead and hit play. If I go ahead and start walking, and then press the Shift key, we can see the difference on the speed of the character. Perfect. The final piece of our puzzle is to be able to turn the character with our mouse. To do that, we only need to rotate the camera inside our player node. And to access our camera inside our script, we could type everything manually, but there is a better way. Simply click on the camera node and drag over to the part of your code you want to reference it. But before letting the mouse go, hold the Command key on macOS or Control on Windows and then let go of the mouse click. Now that we have the reference for the camera node in our code, let's just rename the variable name to camera. Let's also create a new variable for the sensitivity of the camera rotation and give it a low value of 0.05. We also need another variable to save the mouse position on the screen. Call it camera input, and it's going to be of type vector2. In order to fetch the current mouse position, we're going to use one of Godot's built-in functions. The function name is called unhandledInput, and it's going to receive, as an argument, an event. This event can be of any input event type, like a keystroke, mouse movement, mouse click, etc. But we're only worried about the mouse position, so let's check if the event is of type input event mouse motion. We can now fetch the mouse position from the relative property inside our event and store it in our camera input variable. Going back to our process function, we can now rotate the character on the y-axis by passing in the value of our mouse position on the x-axis times the camera sensitivity. One thing you'll notice is that the character is turning to the opposite side that it is supposed to. This can be easily fixed by multiplying the value passed on to the y rotation with -1. To avoid any kind of jitter, at the end of our process function, reset the camera input to the 0 vector. And now we can turn our character on the y-axis. Finally, to handle the x-axis, it doesn't make sense to rotate the player, but rather the camera itself. So, rotate the camera on the x-axis with the same values as before, but with the value on the y-axis of the mouse position. And there you go. We can now fully turn our player in whatever direction we prefer. But we still have one last problem. If we continue to move our mouse on the vertical axis, you can see that the rotation goes overboard. Unless your character was meant to snap his neck, this doesn't make much sense. So let's go ahead and fix this. What we can do is limit the value of our camera rotation to be between two values defined by us. To do that, we use the clamp function, which receives the value we want to clamp, the minimum range and the maximum range. It then returns the value limited to this range, which we will assign onto the rotation on the x-axis. If you now go ahead and play, the character no longer snaps its neck and has a limit to look up and down. We are now done with our player movement, but there is still one thing that's bugging me: the mouse in front of the screen. We can fix that by changing the mouse mode on the ready function. So when the script is loaded, we're going to change the mouse mode to the mode captured. This will make the mouse invisible and lock its position to the center of the screen. If we now click play, there is no longer a mouse on front of the screen, and we can go ahead and start playing with our character. We can jump onto a box, jump to another one, look around, sprint. Everything you need to start building your first-person game. Perfect. I hope you enjoyed this, and that it helped you better understand the basics of character movement in Godot. Don't forget that you can download the project from my website in case you need it. And if you have any questions, leave it in the comments down below. Until the next one, cheers.